Hello everyone, in this video I'll explain the Vivaldi antenna, also known as the tapered slot antenna. The Vivaldi antenna is a planar traveling wave antenna, first proposed by P.J. Gibson in 1979. It was widely used in ultra-wideband and high-frequency applications due to its ability to operate over a very large frequency range. This is what a Vivaldi antenna looks like. The Vivaldi antenna works on the traveling wave radiation principle. When the antenna is excited, the electromagnetic wave travels along an exponentially tapered slot rather than forming a standing wave. As the slot width increases gradually, energy is continually radiated along the length of the antenna. The smooth exponential taper helps minimize reflections, which is key reason the antenna achieves wideband. One important concept in Vivaldi antenna operation is that different frequencies radiate from different parts of the taper. High frequency components have shorter wavelengths, so they radiate closer to the feed region, where the slot width is smaller. As the wave travels further along the taper, the slot width increases. Low frequency components, which have longer wavelengths, continue propagating until they reach a point where radiation becomes efficient. Radiation occurs effectively when the local slot width denoted as L becomes approximately half the guided wavelength guided wavelength, meaning L is greater than or equal to lambda by 2. At this point, the electromagnetic wave strongly couples to free space and radiates. Because this condition is met at different positions for different frequencies, the antenna is able to support ultra wideband operation. The geometry of the Vivaldi antenna is defined by parameters such as antenna length, slot width, and taper rate. The exponential taper ensures a gradual transition from guided wave radiated guided wave to radiated waves across the wide frequency range. In the design process, the minimum antenna length is chosen based on the lowest operating frequency. Since lower frequency requires a large physical aperture to radiate, the exponential slot shape is mathematically defined and the lowest frequency of operation is approximately determined by the antenna length and effectively dielectric constant of the substrate. With this understanding of how the antenna operates and how different frequencies radiate along the taper, we now move on to the simulation results and performance analysis.
Moving on to simulation results, we'll start with bandwidth and uh, polarization. The Vivaldi antenna is inherently a broadband antenna with typical bandwidth range ratio ranging from 3 to 1 to 10:1. This wide bandwidth is achieved due to the continuous radiation along the tapered slot. Coming to polarization, the antenna exhibits linear polarization with the electric field aligned along the slot direction. This is the polarization graph. This graph shows the dominant copolarized radiation confirming the linear polarization. This is further supported by the electric field distribution, which shows strong electric fields concerned along the slot, indicating consistent polarization behavior across the operation band. Moving on to radiation. The Vivaldi antenna is a highly directional antenna that radiates primarily in the end fire direction. The 3D radiation pattern clearly shows that the most of the radiation energy is concentrated along the axis of the taper. The 2D radiation pattern helps estimate the bandwidth and confirms the main lobe direction. Moving on to the parameters of the antenna. The radiation resistance represents power radiated as EM waves. For traveling wave antennas, it is around 60 ohm to 200 ohm. Dielectric substrate effects. These effects control antenna size and bandwidth. Lower dielectric improves bandwidth and efficiency. Common substrates used as dielectric are FR4 and Rogers. This is the Vivaldi HFSS design which we have done, and this is the taper length. Coming to return loss components. The return loss plot shows that S11 remains below minus 10 dB over a wide frequency range. This indicates good impedance matching and confirms that reflections are minimized throughout the operation band. Comparing Vivaldi antenna with other wideband antennas. As we can see, Vivaldi antenna has a very high bandwidth, medium size, and it is a directional antenna. However, it does have some limitations. At lower frequencies, the antenna size becomes large, the feeding structure can be complex, and back radiation may occur if a reflector is not used. Concluding, to conclude, the Vivaldi antenna provides ultra wide bandwidth, frequency dependent radiation along the taper, and directional end fire radiation, making it highly suitable for radar communication and high frequency systems. Thank you.